before talking about design by numbers, design by mouse clicks. Actually, it sounds strange or sounds funny, but anyway, take a look. General GUI-based 3D modeling tools. They are totally mouse click based. Okay. Designed by mouse clicks. Of course, GUI is very effective and powerful tool for computing. People believe that Palo Alto's Xerox lab, located in San Jose, the United States, so-called Silicon Valley, they invented GUI around 20, 30 years ago, and Steve Jobs stole it to their Macintosh operating system. That's commonly believed thing, what happened in GUI world. But anyway, it doesn't matter whether Steve Jobs stole GUI concept or not. Anyway, he made GUI very popular to ordinary people like us, okay? So that is why we use mouse clicks for designing. So take a look. This is actually SketchUp.com's one of the reference tutorial video. This is not regular functionality defined in SketchUp. SketchUp has push-pull, okay, push-pull tool, but this is an advanced plugin for SketchUp to create this kind of very organic shape surface, okay. At first, some meshed, okay, tessellated surface and controlling points, vertices, controlling angle, location by clicking mouse, okay, mouse clicks. So this one looking great, this one looking very nice, but how to reproduce this one to other blank SketchUp environment? You remember how much you click and which point you controlled, but all they just created by accident, okay? By accident. You cannot reproduce exactly same to this geometry again because you don't know the definition. Computer knows the definition, but it's behind the code. It's not visible. You don't know how much angle, okay, this red angle, or which points, which portion of polygons should be selected. And how about this? Based upon that polygon, you break out and you just created push-pull. Okay, now you didn't put the numbers. You don't know the thickness, simply. If you don't remember the thickness, how to reproduce this one again? Exactly same way, okay? This one also created by this surface by accident, thanks to this push-pull plugin, okay? This one also one of the SketchUp.com's tutorial video. This one is one type of push-pull plugin, kind of advanced push-pull plugin, in order to, you can push-pull based upon this very complicated surface. But anyway, my point here is design by mouse click is something like this, looking nice, looking okay, but how to reproduce this geometry using empty new SketchUp file. They don't have definition. They just remember what you have done and save the file. Finalize the geometry, okay? In the same way, take a look at this 3D Max interface. 3D Max modifier, one of the modifiers named FFD. You know what is FFD? Freeform deformation, okay? Freeform deformation tool is very powerful for creating this kind of freeform shape, okay, organic shape, modifier defined in 3D Max design. So take a look this sort of organic shaped geometry. Thanks to FFD, I could simply made a shell making 3D. And even after making this shell geometry, I could modify 3D, okay, in terms of its geometric shape. But still, this one is something designed by mouse clicks, okay? So even if you know how to make this one, take a look. This is front view. Firstly, draw your own section profile. Secondly, you need to make them array copy. And then shell. Before applying modifier shell, you need to use FFD in order to change geometric shapes, okay? Like this. But you remember you used FFD, editable poly, and polygon edits, and section profile drawing, and shell modifier. But you don't know how much. You don't know which control vertices moved, rescaled, how much. You don't remember, okay? In other words, exactly same geometry couldn't be recreated by you, even by you, from nothing again, okay? It's not possible. Because this one created by you by accident using mouse clicks, okay? You don't know how many you clicked, where to click, and so on, okay? You don't remember. But let's take a look this other case, another example. This one is designed by numbers because actually this is Rhino interface. All your computers have Rhino 2 and Grasshopper 2. Actually, we're not going to deal with Grasshopper in deep way. We're going to deal with Dynamo. But anyway, this is done by Rhino plus Grasshopper interface. And take a look. This one is another case of design by numbers. But this is not not Grasshopper or Rhino. This is Rabbit, okay? But same geometry. This one can be exported to Rabbit using solid 3D geometry. In this case, SAT file, okay? Rhino plus Grasshopper creation imported in Rabbit. So even if this geometry is just a dummy geometry in this stage, anyway, it could be created by Grasshopper using numbers, okay? In other words, if you remember the precise numbers you used, parameters, and then you can recreate exactly 100% same geometry on top of Rhino and Grasshopper interface again, okay? Even by Dynamo and so on. So let me quickly show you the case. You also have the files. Okay, please take a look. This one. On the today's lab exercise folder, there are a series of number zeros. Okay, those number zero things are live demo cases, not lab exercise demo. So please open number 0, and you can find out this one of them, okay? Try to open any one of them, max parameter.max file, okay? Your computer's already installed 3D Max by freshman this week. Okay, in this view, you can find out this kind of geometric shape, okay? And after selecting those things using control point, let me show you how to make some changes. Click control points here, and let me move or rescale, okay? So try to find out what's going on, okay? Like this. How about scale? Like this. So take a look. As you know, FFD is really, really useful when you made some changes like this. How about this? Okay, this kind of manipulation anyway applied for your design and geometry creation. Your geometry dramatically changed like this, okay? And also, let me get back to modifier, and how about shell? Shell to create external thickness like this, okay? So now this one has this kind of organic shape, okay? This one is sort of easiest way to create this kind of organic shape in geometric modeling tool. But the problem of this one is all done by your mouse clicks. How to represent, recreate, redesign, remodel this one from nothing. You can make that very similar geometry, but this one couldn't be defined by you. This is the nature of this kind of GUI-based geometric definition, okay? What is the next problem? Okay, if you want to manufacture this one, of course, you can print this out using 3D printers or CNC machine or something else. But what if you want to get some control as well as real manufacture system in order to let computers understand this geometry? In that case, many problems, okay, in this way. And also, let's take a look this one, grasshopper example, the one that I show you right now, just before. Okay, your computer may have Rhino. So please open Rhino. We're not going to use grasshopper right now, but just for your information, we can open the file. Okay, there are different types of files: SAT, 3DM, DWG, GH. Actually, GH file means grasshopper definition. 3DM is, as you may know, this is Rhino file. SAT is 3D solid geometry. As you know, DWG is AutoCAD file. The problem of AutoCAD file here is it's not solid. It's surface-based, ill-defined 3D. I'm going to let you know the difference between those things. Anyway, at first, please open this 3DM file and click Open the file. Okay, in this Rhino interface, actually this is just not just the simple geometry. This is Rhino grasshopper defined geometry and baked out and stored in Rhino interface right now. In this Rhino, you can save as, export, okay? You can save as by very different file formats. So SAT file is one of the standardized representative industry standard for solid 3D, okay? Solid 3D geometry. As you know, DWG, FBX, they are all another famous 3D model file, but they are just surface-based 3D. We already stored the file, so let me close and take a look those different files. Next thing we need to do some live demo is, just for your information, I'll let you know the difference between solid 3D and surface-based 3D. using Revit. So please open Revit, okay? Open Revit, click New Project, New Metric Project, which means please open empty, blank Revit project, okay? And I'm gonna import geometry, okay? Okay, this is, I show you as an example of design by numbers. And something like this one, design by 3D Max, I call them design by mouse clicks. Anyway, next thing we need to know is how to import this kind of geometry, whatever it's 3D Max file or whatever it is, this kind of parametric model file, how to import. Okay, click Insert and simply import CAD, okay? Actually, it's exactly the same to the way we imported the floor plan, okay? On the Grasshopper example, okay, the first case is DWG file. So let's try to open DWG file here. Okay, this is top view actually. So please click this one, default 3D view. Okay, this is default 3D view, and please click views and floor plans. Let's go back to level 1. In level 1, click architecture, and just for your information, let's create worlds like this, okay? And back to 3D. Okay, now we have 3 world objects. Okay, probably 3,000 meter, 3 meter height, and take a look. Is that looking okay? Of course not. Take a look. This geometry is kind of hollow, okay? This is DWG file, which means surface-based 3D. So this is not good, okay? Even if you change shaded view, take a look. In this view, they are all just lines, okay? Simply because you imported DWG file. DWG file is not 3D. So, in other words, this geometry is kind of ill-defined geometry in terms of Revit, okay? Revit always use solid 3D. So let's delete this one, but you cannot delete because it's pinned. So click object and take a look here. There is a pin, okay? So click this pin in order to unpin, okay? And delete it. Again, let's import CAD again. At this time, click file of type and then change SAT file. So let me change SAT and let's open SAT file. Is this okay? And try to change shaded view. Now you see the differences, okay? This is not void, not hollow. This is solid fill, okay? 3D solid object. And click this, unpin, and now it's ready to rotate. And rescale, okay? Move. and click this object, and you can find out base offset. Base offset default 0. What if you put minus 500? And then this one is going to move to minus 500, okay? Anyway, I'm not talking about this kind of design elements and design issues. Rather, I like to bring your attention to handle this kind of external geometry, okay? In other words, if you create something by SketchUp, 3D Max, Rhino, Grasshopper, even Dynamo, whatever it is, they all the subject for your design elements and design visualization in the definition of this tool's functionality, okay? Anyway, this object and wall object, they all interrelated, but this is still geometry, okay? Still geometry. So this kind of geometric definition needs to be something different. So geometric model, anyway, anyhow, you can import and handle in the BIM tool in solid definition, BIM definition. But my point here is it's time to learn something different, not design by mouse clicks. We need to figure out design by numbers, okay? For the first example of design by numbers, I mean, before getting into Dynamo today, Grasshopper today, or visual language, we need to take a look at some programming language-based design. Actually, the term design by numbers, this one is one of the application names. Application developed by John Maeda. John Maeda was MIT Media Lab's professor, and he was the president of RISD, Rhode Island School of Design, one of the top design schools. And his background was computer science. But he very interested in design, so he majored design in his graduate program. So he knows design and computers, so-called design computing major. So that is why he could be a professor of Media Lab as well as the president of the top leading design school, RISD, okay, RISD. And the processing, the first one we need to take a look at is script language-based design approach, okay? The processing language developed by Casey Rias, two guys who graduated MIT Media Lab, which means student of John Maeda, okay? Design by numbers developed by John Maeda, and John Maeda students developed processing language. So let's take a look this processing front page. Actually, some of you may be heard about processing language, but mostly not. This is really famous language for design majors. For example, for freshman students, instead of learning Java, C++, C#, .NET language, they are using processing language as an introductory programming language or elementary entry-level computer programming language. Processing is really powerful, totally based upon Java and Java 3D in order to make some interactive designs and so on. So you can take a look at the website. But we need to take a look some test case, okay? Let's see this window. Let's take a look at series of computer code. Very, very intuitive, easy cases. I believe all you guys here easily understand what this means, okay? Int means integer, integer number. Integer number D equals 70. Integer number P1 equals D, blah, blah, blah. And size, probably window size going to be 640 by 360, okay? We are not sure, but according to the language, probably, and draw gray box, line, 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 probably drawing lines using four different points. So 4 lines, okay? And how about points? Total 6 points, okay? 6 points. And there are total 6 points, okay? Let's take a look at processing. Your computer now has processing. Please open processing and simply mouse over, Control A, Control C, and paste here. So now you paste this very simple definition. What you need to do is click play button, okay? So let's click play button. Take a look what happened. Okay, the window now just popping up and rectangle shape, which means 4 lines and 6 points, okay? Very intuitive. Okay, close this. What if you change the size of window? How about 800 by 400, a little bit bigger than before. And okay, how about integer number d from 70 to 40, okay? And let's take a look what's going on. Okay, window size is bigger than before, and number d shrinking size 40, so this one also relatively small sized. What if you change this one to 100 and play it? Okay, now this one is somewhere, somehow moving. Something changed. Okay, this is so far not interesting. There's no fun. So Control A and delete. Take a look next case. I mean this one. Okay. Mouse over, Control A, Control C, Control V. So let's take a look at this one. Only has 20 lines of code. Okay, 20 lines of code and 2 methods actually. Void setup, void draw. Okay, we don't need to understand what this means. Okay, we don't need to. But let me briefly introduce you. Firstly, size 1600, that's okay. On the setup method, this is method, function, okay? 2 methods, setup and draw, which means setup in charge of configuration of the window, draw in charge of literally drawing something. And for, what is for? In computer programming, especially in Java, C, for means iteration, loop, okay? Loop in with numbers. Another loop inside of the loop using height, which means loop in width, loop in height, very complicated double loop. But thanks to such double loop, computer doing recursively again and again, quickly, without any problem. For what? Drawing ellipse, drawing circle, something like that. So if you play button, click play button, let's take a look. The final output of this drawing, okay? Thanks to this recursion, thanks to only few lines of code, you can easily draw this kind of drawing. Okay, this is not the end. Actually, you can control. Actually, there is no fun. So, originally, take a look. I just kill this one single line using 2 slash. 2 slash will make this line dimmed, okay? Dimmed means it's a comment, okay, nothing. Instead, remove 2 slash upper one. Float size is distance at this time, not fixed. 500, 300, fixed. But now it's mouse X, mouse Y. What is mouse X, mouse Y? Actually, we don't know, but we can refer to that. We can imagine probably the location of mouse X pixel and Y pixel. So if you change this one, what's going on? Okay, according to your mouse movement, center point always relocated by exactly center point of your mouse. Okay? Okay, more changes. The size can be defined by size divide max distance multiply 66. What if you change this number 66 to 100? Let's take a look. Okay, little bit bigger size, and at the end, as a result, totally different. Actually, not different, similar, but changed size. Okay, what if you change this one? How about 20? Okay, now this one, you cannot find out the external boundary of this circle. Now it always, take a look, the proportion. The radius of this circle increasingly changed from your location to outways, but in this case, you cannot figure out the last size, which means totally white colored, okay? But anyway, it's still working, moving. How about this one to 200? It's too big, I think, but anyway, okay. Anyway, this one is working like this. Actually, it's not easy to figure out why this one made such changes, but if you understand the computer code and if you try to figure out the mechanism, algorithm defined in this simple code, and then there is no suspicious things in this kind of design, okay? In this kind of visualization, creation. Okay, let's take a look more example for today's lab exercise number 1. Before doing that, let me open the processing website, okay? Processing.org. In this website, there are a bunch of exhibition cases, very advanced professionals' works done by experts. Also, amount of tutorials, okay? Tutorial files, tutorial video, YouTube video, many things you can take. And also examples. This example, all processing, all compiled with Java environment. So if you install the JRE, Java runtime environment, you can take a look all those things on top of your web browser, okay? Array2D example, it looks not that good. How about this one? Follow, okay? Follow, this one also use something similar to physics algorithm, okay? Mouse movement, physics algorithm, and your proportional locations, and so on. So this one is named follow, reach, something else. How about bouncy bubbles? This one has bouncing, and they are collided and react, okay? This one use kind of physics engine, okay? You know the famous game, okay, Angry Bird. It's famous because it used physics engine, okay? Exactly same real world physics engine. Also this one totally based upon physics engine. At the end, this one all day gonna be static, okay? Anyway, here are the code, okay? You can recreate this one on top of your, okay, let me click and let me open this one in processing environment. Play. Okay. Here it is, okay? You can recreate anything, any of them. And actually, I show you some 2D cases, but this one totally based upon Java 3D too, which means there are a bunch of 3D cases, 3D examples, architectural design examples, interior design examples, amount of very, how can I say, mind-blowing examples you can find out. That is why lab exercise number 1 is try to find out your own, in your perspective, find out something mind-blowing example and take a screenshot. That's the lab exercise number 1. Anyway, take a look. This is so-called design by numbers, okay? The last case, last example, I already loaded in here. Okay, under the lab exercise folder, please take a look, number 0, processing. I saved the file Substrate. So let me open Substrate. Okay, double click Substrate. And actually it's 270 lines, comparatively long lines. But this one is based upon random algorithm. Let me play. Okay, at the beginning of this animation, looking something boring, but anyway, randomly picked points are starting point, and they are growing. If they meet some other side, it's going to stop. But anyway, they're gonna repopulate. There are some child lines. So okay, child lines and some more lines like this. Totally random algorithm base. Okay. Random algorithm defined by processing language. If you click anytime, anywhere, this one going to restart. Okay, take a look. The geometry is looking like some development of cities, urban area, whatever. But anyway, the geometry, this drawing couldn't be recreated never again. Okay, this is totally based upon random algorithm. So it's not easy to recreate this geometry. Click again and then restart. Okay, so this is another example, another case you can take a look. Okay, we're gonna move to visual language, but before moving to visual language based design, let's have a break. Okay,